Hi friends, welcome to Rishi Learns Tech. Today I would like to discuss with you about what is PCA, Principal Component Analysis. Principal Component Analysis is a technique that we are using as a part of dimensionality reduction in data preprocessing. When we are doing data preprocessing, there is a section called feature engineering, which means we are handling the features. For example, if we are taking a data set with hundreds and thousands of features, what will happen is many of these features will not be contributing highly to get the actual output or to get the prediction. So what we will do is we will select some specific features which is having higher predictive power. So PCA is used for selection of these features. So principal component analysis will analyze the entire data set and identifies the relationship between each features, and soon after finding the relationships, if there is any redundant data or redundant features in the input dataset, PCA will summarize the redundancies and it will make it as a one component, or that multiple features will be combined into a single feature. This is what is happening inside the principal component analysis. So that if there is a data set having 10 features, and if 3 or 4, if 4 of them are having redundancy, we can reduce this 4 features into one features, which is the summarized version of the 4 input features, so that the dataset before training will only have 7 number of features in it. The advantage of using principal component analysis is we can reduce the amount of computational power that is required for training the model. We can do some other techniques like noise reduction and handling images. Actually, there are some series of steps that we are following for doing principal component analysis. We know that our dataset can be represented as a matrix when it comes to the linear algebra. So what we are doing is we will subtract the mean of the entire feature from each of the data point, so that this process is known as the centering of data or normalization. So each of these data point will be having independencies. After that, we will be finding the covariance matrix. The covariance matrix will give us the relationship between each features. After that, we will find eigenvalues and eigenvectors. The eigenvector will represent the direction of each data point, and the eigenvalue will represent how much the data point is scaled. After doing this, we will have some eigenvectors. All these eigenvectors are called as principal components instead of calling as features. Actually, they are features, but they are the summarized version of the redundant features, and now we can call it as the principal components. So we have to select the top performing principal components. How can we do this? What we are doing is we will select the principal components having higher predictive power. This components can be added into the dataset by replacing the older features which is having redundancy. This process is known as projecting of data. These are the steps inside the principal component analysis algorithm. The first step is normalization or subtracting the mean from each data point. The second one is finding the covariance of the matrix to identify the relationship between the features. The third step is finding eigenvalues and eigenvectors. We can call it as eigen decomposition step. Here we will find the principal components. The fourth step is finding the top performing principal component. The fifth step is projecting the principal components into the dataset by replacing the older features which were redundant. So these are the steps inside the PCA. As an optional step, we can do one more process called whitening. In this whitening technique, what we are doing is we will find the inverse of the matrix. So whenever we are finding the inverse of matrix, the covariance matrix will be converted into an identity matrix, so that it will become unit variance. So that as the covariance matrix is representing the feature relationship, And if this covariance matrix is converted into an identity matrix, the value inside that matrix will be 1. So this 1 will represent the unit variance, which means each of these features have become linearly independent. Otherwise, each of the features have become independent by completely eliminating the redundancies within them. Widening is an optional step that we are doing, but all other steps is a must. So I have conveyed what is principal component analysis, where this principal component analysis is used in a machine learning project, and what are the steps inside this PCA. So I hope you like this video. So please hit that like button, and if you want more content like this, please consider hitting that subscribe button. So thank you for watching for this much amount of time. Until we see in the next video, bye.